In this video, we're going to look at some worded problems involving exponential and logarithmic equations. So let's have a look at part A, or example A, or 2A. Money is invested into an account paying 3% per annum compounded monthly. How many years and months will it take for the investment to triple in value? Okay, so it doesn't matter how much is invested so much, it's more whatever's invested. It's, we want to work out how many years and how many months it's going to take for it to be 3 times as much. So what we're going to do is, let's say $100 is invested. Okay, so by the compound interest formula, okay. Now, if you're not sure what the compound interest formula is, some of you may know this already. It's A is equal to P outside of 1 plus R to the power of N, where R is the interest rate per period and N is the number of periods, a number of compounding periods. Okay, so by the compound interest formula, okay, all right, we want to work out how long it's going to take for the investment to be worth $300. Okay, is equal to 100 outside of 1 plus. Now, the interest rate's per period and it's compounded monthly, so it's actually going to be 3/12% per period. Okay, so it's going to be 3%, okay, over 12, okay, to the power of n. So really, we want to work out, really n is the number of months, because it's compounded monthly. Okay, so the n represents months. So let's solve this equation now for n. Okay, so dividing both sides by 100. Okay, I might just do it on this side here. 3 is equal to 1 plus 3% on 12 to the power of n. Okay, we're going to take the log base 10 of both sides, since the calculator's got a log button that we can use. It doesn't matter what base you use, but since the calculator can work out logs of base 10, we can conveniently use that. So what we're going to do is take the log of both sides. So log base 10 of 3 is equal to log base 10 of 1 plus 3% over 12 to the power of n. Okay, log law number 3 states that the n in the right hand side of the equation, the n can move out to the front. So I'm just going to continue it on the next line here. So log base 10 of 3 is equal to n times log base 10 of 1 plus 3% on 12. Okay, so far so good. Then we're going to make n the subject of the formula. We're going to divide both sides by log base 10 of 1 plus 3% on 12. Okay, so n is equal to, okay, and so it's going to be log base 10 of 3 divided by log base 10 of 1 plus 3% on 12. Okay, so let's put that in the calculator, enter that in, and see what we get. Okay, so log base 10 of 3, okay, divided by log base 10 of 1 plus 3%. Okay, that's the great thing about these calculators. You can directly enter in these percentages. You don't have to worry about converting it into decimal. And we get 439.99, which is, if we round it to, so 2 decimal places, it's 440 months. Okay. Okay, so it's going to take 440 months for the investment to triple in value. So what's that in years and months? Okay, 440, if we divide that by 12, that gives us the number of years. So that's going to be, so I might just do that different color again. So in years, okay, and months, okay, 440 divided by 12. We only want the whole number, okay, is equal to 36. Actually, that's 36 2/3. So Shift SD will give you the answer in mixed numeral format. All right, and that's going to be 36 years and 8 months. All right. Is that a good investment? You know, well, that's up to you to decide whether it's a good investment or not, but this is something that's very useful to work out how good an investment is. You can compare it against, for example, putting your money in the bank. What would the bank return? So it's very useful in finance. Let's have a look at another example now. And this example is to do with radioactive decay. So part B, a radioactive substance with a mass of 250 grams decays according to the equation A equals 250 times 3 to the power of negative 0.02 t, where t is the time in years. So part A is find the mass of the substance after 20 years. Okay, fairly straightforward. We just substitute the 20 in for t. And for part B, find the time taken for the substance to decay to half the original mass. And this is what we call the half-life. So the half-life of a substance, for example, is just the amount of time it takes for half of that mass to decay. Now, it's actually a very important number. Okay, so for part A, all right, mass of substance after 20 years. Okay, so A is equal to 250 times 3 to the power of negative 0.02 times 20. Okay, and entering in that into the calculator. Okay, so just direct entry times 3 to the power of negative 0.02 times 20, and we get 161 years. Sorry, 161 grams. So, okay, and we'll do that to the nearest gram. Yep. And for part B, okay, find the time taken for the substance to decay to half the original mass. This is a bit like part A, where you're asked to find how long it takes for something to double or triple in value. This is effectively the same thing, except we're just trying to find the time for the mass to halve in mass to half of what the original mass was, as opposed to doubling. So like money, for example, or investing money. This is sort of going the other way around. Okay, so if we're starting off with 250 grams, we want to work out how long it's going to take for the substance to decay down to 125 grams. Okay, so 125 is equal to 250 times 3 to the negative 0.02 t. Let's divide both sides by 250. Okay, so if we do that, 125 on 250 gives you half. Is equal to 3 to the power of negative 0.02 times t. Now let's take the log of both sides. Now let's take, okay, so taking the log of both sides, so log base 10 of half, okay, is equal to log base 10 of 3 to the negative 0.02 t. Okay. Now, the t on the right hand side, the t can come out to the front. Okay, again, log law number 3. So you see, log law number 3 gets used quite a lot. In fact, very useful law. That's equal to t times log base 10 of 3 to the power of negative 0.02. Okay. We could take out the negative 0.02 as well to the front, but I think if we just make t the subject there, this will still work. Okay, so you might take the entire power out the front, but I think we can just take the t out. We can take part of the power out and it'll still work. So, alright, so let's divide both sides now by log base 10 of 3 to the negative 0.02. Okay, so t is equal to log base 10 of half divided by log base 10 of 3 to the negative 0.02, and t equals, and we'll just again just round it maybe to 1 decimal place, doesn't really matter. So log of half, okay, and we're going to divide that by log of 3 to the power of negative 0.02. Oops. Let's put the bracket there, sorry about that. Okay, we get 31.5 years, just to 1 decimal place. So in other words, if we wait roughly 31.5 years, the substance will decay to half its mass. Now, we can test that solution. How do we know that we got it somewhat correct? So if you take 31.5 years and substitute it in for t, we should have a value of a that's close to 125. Okay, so let's try that. 250 times 3 to the power of negative 0.02 times 31.5, and we should get a value pretty close to 125, and we do.